Okay, now we can fill in to our general shape of the integral the -2 for the lowest y value, the 4 for the highest y value, the length of that horizontal slice, and dy. That's the thickness of the horizontal slice. All right, especially pay attention to the parentheses here. Since all of these are going to use subtraction, in this case it will be the right hand function minus the left hand function. Always right minus left, since on the right that's the larger x values. Since it's using subtraction, I gotta have parentheses around that second function there. I just go ahead and put parentheses around both of them just to be in the habit. And that's because that minus sign is going to get distributed through the parentheses. So when I start step 4, which is simplify and solve, I'll do a subtraction on the 1/2 y squared, and then I'll have a minus minus on the 3, so it'll turn into a +3. Combined with the +1 will give me a +4. And then after that, it's a straightforward reverse power rule, raise and divide. And the only odd thing is that you may not have done very many of them with the variable y, but you treat it just like you would if it was a x or a t. You raise and divide each of them. That interesting case in the middle, the number 4, y plus 4, becomes 4y. When you take the antiderivative of 4, it usually is 4x, right? But this integral is with respect to y. The dy at the end, one of the reasons why it's useful is that it tells you what variable goes on to the constants when you take the antiderivative. And then you can plug in the numbers. This just becomes a bunch of fractions, and it simplifies to 18. All right, so next one is another example. This one is going to be immediately a little more complicated because it's going to be the area between two curves, and the curves themselves cross between the limits of integration. All right, here's the statement of the problem. Find the area between y equals tangent x, 2 sine x, and for x between -pi/3 and pi/3. All right, so here's the picture of this. I had to remind myself what the graphs of sine look like. That's the wavy curve up and down. The fact that it's 2 sine x means that the amplitude will be 2. So it'll go all the way up to 2 and all the way down to -2. But it has the same period as usual, so it comes back to the x-axis at 2 pi and crosses through the middle at pi. The high point is at pi/2. Now the tangent, the graph of tangent, for that you can remember that it has those vertical asymptotes at pi/2 and -pi/2, because tangent is the same thing as sine divided by cosine, and so where cosine would have been 0 is a vertical asymptote for tangent. So there's the shaded area that is we're trying to find. And you notice that the curve of tangent crosses right through sine at x equal to 0. And then there's a beginning and an ending point where they cross as well. So we need to find those beginning and ending points specifically, but also we can solve in the process that they cross at 0. We need to know where they intersect. And this is a type 1. If you're to be completely honest about it, you could make it into a type 2. But then you would be messing around with some more complicated functions, because you'd have to use the inverse trig functions or something like that and make sure that you are using the inverse trig functions correctly. So why not use a type 1 if you can? This one isn't forcing you to use type 2. So that means I want to find those x values where the curves cross. So I'll need to solve the trig equation. Tangent x equals 2 sine x. And now it's time for a little trig review. Notice I put over here the unit circle, And this is where I point out how to draw a unit circle the easy way for anybody who hasn't seen it. It is just the counting numbers 1, 2, 3. And those are the numbers that are under the square roots. 1, 2, 3 are under square roots. Then you have to divide them all by 2. So you get a half, square root of 2 over 2, and square root of 3 over 2. And once you got those numbers, those three numbers are going to be the sines and cosines of the three key angles, pi over 6, pi over 4, and pi over 3. So to solve, put everything in terms of sines and cosines so that tangent is sine over cosine. Then multiply both sides by the cosine, and you see that you'll have two possible solutions. One is that the sine x is equal to 0, and that gives you the solution that x is equal to 0. And the other is that the cosine of x is equal to 1/2. That's when sine is not 0, and you divide both sides of that equation by sine so that you get 1 over cosine equals 2, or cross multiplying, cosine is equal to 1/2. So those are the ones that we're interested in, because that's not right, giving you the answer 0. And so looking at the picture, cosine is equal to 1/2. That's on the x-axis, and that's that first number that I marked, 1/2. And that's corresponding to the angles pi over 3 and negative pi over 3. So those are the ones that I want. Negative pi over 3 and pi over 3 on the picture are where they cross.